Reverse engineering a part for 3D printing doesn't mean that you need to recreate the exact geometries. You can perform optimizations and also adaptations of the part geometry in order to make it perform the way as the original part is. So in this video, we are going to cover some of the challenges that you are going to face doing that kind of process. And also we are going to see a case of study where I can show you how I solve and gave a solution to a customer. So let's start talking about the challenges. So we can, on plastic parts, if we take a plastic part as it is coming from the mold and we put it on a 3D print, not on a 3D printer, we're going to see potentially a lot of overhangs, for example, when we don't have an even surface where to put the part for 3D printing, which is going to mean that you need a lot of supports on the way and are maybe painful reprocessing thing, right? So overhangs is the number one. The other challenge that you're going to face is the small features, especially when they are there just because of thickness rules on plastic parts, which are a different thing from designing for 3D printing. So sometimes replicating those small features doesn't worth it. They're going to make your part more complex and they're going to be a pain. Not only by modeling the features, sometimes it is a time-consuming task that you could, by understanding how the part is being used in real world, you can just simplify all those and have a better part, or well, at least a part that performs the same way. The other challenge is the manufacturing method. You are running on 3D printers, so that's additive manufacturing compared to an injection molding. And there are some stuff to take in account, like, well, overhangs is one of them, but also you need to take in account the finished surface, if you are going to have a thread. Also, the orientation of the layers can make a great or bad impact on the performing of your part in real life situations. For example, taking loads and also performing in other type of situations like being watertight or air pressure tight. I got a request for replicating this part, and to be honest, it is a challenging part, especially because of the manufacturing process. It has on the original design, you can see that it has a lid, and actually sealing 3D printing is a little bit difficult, especially on the finished surface, or you need to throw a bunch of RTV all around and stuff like that. So the first thing that I saw when I was looking at this design was to, okay, let's remove that lid and just make an enclosure. But also the challenge of making an enclosure without the lid is going to mean that I will have internal supports. So for compensate that challenge, I will have to create some features for do a variation of the 3D printing orientation so I can minimize the impact of those supports. Then the other aspect, a really important one, is that now that I'm removing the lid, I can remove some avoidance for the screws that are present in the injection molded version. So this is great because I can get back volume. This part is for airtight application. It is kind of a ventilation on a ventilation device for pets when they are on surgery. So it should be airtight, and we should keep also the finished surface of these two outlets. Well, one is outlet or one is inlet, but there are some holes that attach there. I don't believe they are going to be under a lot of pressure. If I'm not wrong, it is just going to be under 0.3 pascals of pressure. So it's not going to be a huge pressure. The other challenge that I can clearly see in here is this big thread that is for this, I'm not sure, it's a regulator or something like that. But the challenge of this special one is that I don't want to destroy the original part for take out the headset thread and then push it on my 3D printed part, because this sounds like I need a lot of heat, and a regular soldering tool is not going to help me much. So I will prefer to make the thread directly on the plastic. So I gave some extra material for make that. So it also had its challenges, and the big challenge here is to make the seal actually. So let's take a look to the model that end up in my hands. Okay, so this is the 3D model, the original one. As you can see, it is basically it's a solid body with a shell of 2mm thickness, and then just add adding with the other features for the inlet, the outlet. We have the thread in here, which, by the way, I printed the wrong thread in here. So that's one of the other things that also happens in the process. That's more like a spoiler. Okay, so how do we can orientate, the orientation of this part can be, in order to avoid to have a lot of internal supports that are not going to be acceptable for this. So the way that I found was to make this flat in this face. So the model is going to be orientated like this, and then I try this other one that is having, let's say, a disadvantage. That is the amount of surface area touching the build is not going to be as great as this other one. But this other one has the thing that the angle is less steep. So this one is 25 degrees, this other one is 30. And let me show you some of the results of these prints. So as you can see, the surfaces on the inlet and outlet are totally unacceptable. For more that I can sand the thing down and also use acetone, as I'm using ASA, is never going to be acceptable. It's a lot of work, it's a pain. So which potential solution could we use in here is, okay, so based on this, I can see that the outlet on the 30-degree angle is better, even if it doesn't has the amount of surface area that I mentioned before. It seems like it doesn't make a difference. So the area isn't a problem of the adhesion on the bed. So I jump into that one. But in order to avoid the supports below the inlet, what I did is this. I did an extension of the geometry itself, and I added this groove. So for me, it is going to be easy to just, after printing, just make a cut with a saw or a Dremel or something. Actually, it came out pretty good. The surface finish coming out of the printing process was okay. Then with a little bit of love, a little bit of sanding, and also acetone, the thing looks way much better and feels way much better. Other of the challenges on the thread itself. So as you can see, the previous model that I shown, let me come back to this other model state. Yeah, so it used to be smaller and the pitch was wrong. So I don't know what happened, but it was from a pitch of from one, the one that is wrong is, I did a pitch of 1 millimeter, and then remeasuring the thing, it was 1.75. So this is a pre-thread feature. So it is not the intention to make the thread itself, because it's going to be challenging as well, because of the printing orientation. To make something very sharpy, it's going to end up into something that is not going to work well. Yeah. So I did it this way. Then I took the aluminum part that goes in here, and then just forced a little bit the thread, and it worked fine. I'm a little bit worried about the perpendicularity of this axle to the surface, because depending on that, it is going to drive the compression on the O-ring in here. I'm not fully sure if this O-ring is really making something in the original part, to be honest, but we will have to include it, right? So we will find out once we send this to the client and check. I mean, the other option is to destroy the original one, take the heat insert and just heat it somehow and push the thing there, and cross fingers that there is not going to be a leakage. Okay. Okay, so let's take a look to the 3D printing settings and other stuff. Okay, so as you can see, here at the right, we have the one with a little surface area, and at the left, the one with a larger surface area in contact with the bed. So if I'm not wrong, the one of 30 degrees is the one on the right, the one with 25 degrees is the one at the left. So I use 3 support type. It simply jammed the entire thing. So the bad surfaces finishing are coming from this type of support, but as we can see also with 30 degrees, we are not going to have supports for this inlet. So that's something that call attention to say, okay, let's persist with the one with 30 degrees instead of 25. The other aspect that I painfully I found it okay at the beginning, but after doing it, it was not that fine, is the internal supports. So as you can see, 3D printing supports internally 3 type. I was able to remove them at the end due to the big holes that we have available along the part with these 3 holes. It was enough for remove them, but in reality, it was not a pleasant thing to do. But definitely, it is not a mess or a no-go at all. So I would say if it is the only way to go, I would say it is acceptable enough. Okay, great. So as you can see, we don't have supports below the inlet, which is totally fine. And by adding this extension, it is going to work as a support for the part to just be generated without troubles. Looking at the left side, we always going to have these overhang problems, but it's not a problem at the end. And looking internally, we got some supports, but they are not as messy and huge as they were in the other 2 options. So I'm happy with this these results, you know. Okay, so now let me give you a tip when printing on ASA if it is a generic brand. So I had to create a custom setting So I will show you my setting here. So it is called fan. And when I take a look to the setting, for a reason that I'm not pretty sure why, the fan speeds on the generic ASA from Bamboo usually have these other values on a very high value, and that makes the fan to run at 100% or 80%, and that makes your part to warp. That's something that you don't want to have parts warping. So it is as simple as just come to here, create a new profile, come to cooling, and modify the cooling overhang threshold to these values. I believe we could also leave it at 0. It's not going to affect. And also especially this one. So the fan speed for overhangs, that's one of the ones that I believe is going to be problematic. So I, by mistake, started this print without having these settings on. So I was running on generic ASA, and the thing was warping all the time. I did it 3 times in a row, and I just stopped and say, hey, hold on. This is not usual for me. And so then I got to understand that, I forgot to use my setting for the fan on ASA material. Okay, so there you have it. If you want to learn about how to design in SolidWorks, I have here a basic tutorial playlist that you are going to enjoy. And if you want to jump into design in Autodesk Inventor, you can also click in here where I'm showing the tutorial of how to speed up, ramp up in Autodesk Inventor if you are a SolidWorks user. Enjoy.